All right, so now that we've defined our event and we're broadcasting out that the event has happened at the correct time, the next step is to set up an actual observer that cares when that event has happened. So the contextual message controller is what needs to know or what cares when a contextual message has been triggered. And so what we're going to do here is create what's called an event handler, which is just a special function that is called in response to that event happening. And then we have to subscribe to the event. So we'll start by writing the event handler. So the thing with event handlers is you want to figure out what's the event that we're going to handle. It's the contextual message triggered. That's the event right here, the contextual message triggered. And you see the little lightning bolt icon in Visual Studio. That means that it is an event. So what I'm going to do is write a function. So private void on contextual message triggered. And it's important to call your event handler to name it based on the event that it's handling. So this is the name of the event. The event handler should just say on and then whatever the event is called. So the naming convention to keep track of is the event is some past tense thing, typically something that just happened, and the event handler is on when that thing just happened. This is what we want to do. So what do we want to do? We want to show message. So I guess what we'll do right now is kind of set up something similar to our test that we used to have, except now it's not going to be called in start. It's going to be called whenever the contextual message is triggered. So let's just set up something pretty basic here. And we'll start the coroutine. We'll give it a simple message and just a quick duration. And so we've made this event handler, but you can see it's like grayed out in Visual Studio, which means we're not using it. So what we need to do is subscribe to the event so that our game understands that this is the event handler that should happen when this event is invoked. So what we're going to do next, in Unity, the typical pattern for subscribing and unsubscribing to events is to do it in on enable is when you would subscribe, and then in on disable is when you would unsubscribe. And we'll talk about that in a second. So subscribing is easy to understand. If we want this to happen when the event occurs, we need to subscribe to the event. So the reason we made this thing public and static, that's our event, it's public and static. The reason we made it that way, so it's really easy to subscribe. So when you have something that's static, you don't need a reference. So that means we can just directly type the name of the class that owns the event, which is our contextual message trigger, and dot, and we can look for our event inside. There it is, the lightning bolt. So contextual message triggered, and then you use a plus. So plus equals, which is just shorthand for adding whatever used to be in there. We're going to add to it some new function. So remember, this is like a delegate type. It's a delegate, so we can store functions into this variable. So the function we want to store in this is our event handler, which is called on contextual message triggered. So we are storing our event handler in the event with plus equals. Now, plus equals is just a special shorthand operator that's the same as saying this thing equals whatever it used to be plus this new thing. You can use it with numbers and, anything else like that. So I'm just trying to explain this is not something special just for events. It's just the normal plus equals operator you've used before. this is all we need to get our setup to work. So let's save everything and test it out. And so what in theory is going to happen is when the player walks into the trigger, the event will be invoked. We're raising the event. We're announcing to the world this thing has happened. Meanwhile, our contextual message controller, which is controlling our text up there, is going to be listening for when that event happens. And when the event happens, we're going to handle the event with this function here. And so this is essentially a method for having these two classes talk to one another without giving either one a direct reference to one another. So it's maintaining a encapsulation or decoupling so that, these two classes are totally disconnected from one another and not reliant on one another, so I could change things without breaking one or the other. As opposed to, say, creating a public variable for something of the type contextual message trigger and then having a direct reference to that thing and changing stuff about it. Or maybe it'd be more like vice versa. Our contextual message trigger could have a public variable for something for a contextual message controller, and then we could show or hide the text directly right here. But that's sort of like a violation of the separation of concerns, right? We want this object to only do one thing. It's going to only do what a contextual message controller ought to do, which is show its message or hide its message at the right time. And the trigger is only going to do what a trigger should do, which is figure out when it has been triggered and announce that it was triggered. So this just allows us to keep our code more siloed, I guess you could say, and less intertwined and tangled up with other classes. So let's just see if it works. I think it's going to work, but there's still one extra problem, but we'll talk about that if it works. So if we walk into the trigger, we want to see it say testing, and it did. And it should go away after 2 seconds. And if I walk back in, it'll say testing, and it'll go away after 2 seconds. So that's cool. Let's talk about what the problem is. So remember we talked about subscribing and unsubscribing, which is covered in the observer pattern here. It'll tell you all about why you need to subscribe and unsubscribe, but the essentially what will happen is that when we subscribe to the event here, we are basically giving the event a function that exists in an instance of this class. And if that instance of this class were to go away at runtime, and then we triggered the thing, we would be trying to call a reference to something that doesn't exist, which would give us a runtime exception. So I think we could maybe test that if we leave our game running and we delete our contextual message controller. So I'm going to leave the game running so that these changes don't actually get saved, because they're not things I really want to do. Let's see. So our contextual message controller is on this game object. You can see it right here. So if I were to remove this component and then go run into the trigger, you can see missing reference exception. The object of the type contextual message controller has been destroyed, but you're still trying to access it. So what's up with that? The subscription here is essentially giving our event a reference to this, to the instance of this thing. And when we delete this, and then the player goes into the trigger, we invoke our event, which still contains a reference of that event handler when we subscribed, but that object is gone, so we get the null reference exception. So to safeguard against that, the last step of the observer pattern here, let me go ahead and stop my game, and hopefully my component comes back. Yeah, it did. Excuse me. So anyway, what we need to do is unsubscribe. So in onEnable, we are subscribing, and so onEnable is a Unity message that gets called whenever this object like turns on, is enabled. So that's basically like if you were to check the little checkbox in the inspector, right? Boom, onEnable will get called over and over as many times as it's enabled. And then next is onDisable, which is the same deal. Whenever the object gets disabled, which could be just temporarily deactivating it or deleting it, etc., this will get called first. And you can see this kind of looks like like it's its own event handler. And these types of Unity messages are essentially special events that Unity is invoking, the Unity engine is invoking. So we're kind of using something like the event pattern all along with Unity. But in this case, what we need to do is remember to, whoops, I hit a hotkey that is not what I meant to hit. There we go. In this case, we need to unsubscribe so that when the object gets deleted, it's no longer, our event is no longer holding on to like a ghost reference of a previous game object that has been deleted. So when you unsubscribe, you just need to make sure you use minus equals here. So to subscribe, you use plus equals. To unsubscribe, you use minus equals. And again, in Unity, the typical way you're going to deal with that is you subscribe in onEnable and you unsubscribe in onDisable. And you can just trust that the Unity engine will, as soon as it starts up, as soon as this script starts up, it will subscribe. And as soon as this script goes away, it will unsubscribe. And you don't have to worry about it more than that. So that is the event pattern, the observer pattern in Unity. It has given us a way for these two things to communicate without us having references to them in our classes here. Now, I mentioned there's a way to simplify it a little, so let's work on that. But before we do, let's go ahead and commit. Did I make any changes to my scene? Why isn't my scene coming up? Oh, there it goes. Honestly, can't remember if I did or didn't. I don't really think I did. I think I just, I see there is a change here, but I don't know if that came up for anything meaningful. So I think all we need to do is save this script. So what did we do here? We subscribed and unsubscribed. So we have our event handler and we subscribed and unsubscribed. All right, let's go ahead and commit that and push, and we'll work on simplifying this a little bit in the next video.